Hello, everybody. Hopefully, you're doing well. In this video, we're going to take a look on linear equations and rational equations. You know, uh, in a formula, you can see if the variable is degree 1, degree 2, etc. But we're gonna begin with a general definitions of a linear equations in one variable. First of all, what's gonna happen? We're going to solve linear equations in one variable, solve linear equations containing fractions. Those will contain rational expressions with variables in the denominator and also recognize identities, conditional equations, and inconsistent equations or contradictions. And also, at the end, we would solve some applied problems using mathematical models. So, as I said, the first look we're going to take, we're going to begin with the general definition of a linear equations in one variables. As you can see, linear equations in one variable is an equation that can return in the form ax plus b equals 0. Of course, you can have multiple parts of it where we need to distribute, so we have multiple constants, etc. But at the end, you will see only one variable that we call x. Only one variable that we call x, and we can have a, b, c, d, e, f, where those letters represent real numbers. But remember, the coefficient of x cannot be 0. For example, a linear equations can be 2x plus 3 equal to 0, or you can have 5 times 3x minus 1 plus 2x minus 6x plus 3 equal to 0. So you see, after you distribute and combine like terms, it's gonna bring you back to the form of ax plus bx plus c. No matter what type of expressions we have, as long as at the end, when you distribute and combine like terms, combine the terms that has x's together, combine the terms that has constant together and set it equal to 0, it's a linear equation. There is no power 2, power 3, there is no roots, there is no radicals, which is root, there is no absolute value. So it's only linear. Linear, that means Zach, when you graph that it would give, it's like when you have a linear functions, okay? That's give you a straight line. But this one is about equations. So general equation equivalent, for the equations, we have a variety of them. So an equation can be transformed in an equivalent equation by one or more of the followings. I just give you one of these. Like when I said 5 times 3x minus 1 plus 2x minus 6 times x plus 3, it's a general form. So simplifying expressions by removing groupings. For examples, if I have 4 times x minus 2 equal 2x minus 1, okay, and 1 plus 1. So first of all, I need to distribute 4x minus 8 equal 2x plus 1. Now, if I add 2x from both sides, you're gonna have 2x minus 8. Sorry, if I subtract 2x from both sides, I'm gonna have 4x minus 2x give you 2x minus 8, and 2x minus 2x give you 0. So we have 1. If I add 8 to both sides, I'm gonna have 2x equal 9. As you see, if I divide both sides by 2, we're gonna have x equal 9 over 2. But it's not where we're gonna go. Most of all, it's not solving the equations right now, but it's to show you that simplifying, for example, here, if I subtract, we're gonna give me 2x minus 8 equal 1. If I subtract 1 from both sides, I'm gonna have 2x minus 9 equal to 0, and this one still give me the form ax plus b equals 0. You see, b is negative 9 and a is 2, and you set it equal to 0. So no matter how you have it, you can still simplify. And remember, when you add, we can add or subtract real numbers from both sides. Remember that. If you add and subtract, oops, sorry, I do a wrong notation, you know. So if I add or subtract from both sides, for example, that's what I just did. If I have 4x uh, minus 11 equal uh, x plus 2. So first of all, I can subtract x from both sides. That give me 3x minus 11 equal 2. Now look, when I have 3x minus 11 equal 2, I can subtract 2 from both sides as well. Because now I'm not showing you that I solved. I just rewrite it to show we have a linear equations. As you can see, we still have ax plus b, where a is 3 and b is negative 13. So we can have that, or you can multiply or divide by the same non-zero quantities on both sides, like this one. Let's say for the same expression, suppose we have 3x minus 13 equal to 0. If they ask us to solve, we can add 13 from both sides, when that would give you only 13 3x equal 13. Now we said you can divide or multiply both sides by a non-zero number. So here I can divide by 3. So you see we have x equal 13 over 3. Some very few examples to happen. But sometimes you can interchange. Remember, if you have x equal, if you have negative 2 equal x, it's the same thing saying x equal negative 2. It doesn't matter in which side you have the variable. So you pay attention to the equality sign. Now, solving some linear equations, because here, instead of just, showing you that we can write any expressions in the form ax plus b, we're gonna just solve, because it's not only ax plus b, we know this is a linear equations. But now, if they ask us to solve a, all you need to do is subtract 5 from both sides. Okay, remember this one is gone, so you have only 4x left equal 24. Now, use the rules we just said, multiply or divide the same non-zero quantity on both sides. So here we can divide by 4 from both sides. It's not all the time we're gonna be that lucky to obtain a number, a whole number. Sometimes it might be just a fraction you simplify, or you can express it in decimal if asked. But in this case, 24 divided by 4 is 6. So that would be our good, beautiful answer for this one. All right. In some cases, you see this one? Our goal is to obtain an equivalent equation with x isolate in one side and the number, real number on the other side. That's what we did. We isolate for x on one side. And then what we got later, as you can see, we have, after we simplify, 29 minus 5 is 24. Now you have only one x term on the side, one real term on the other side, so we divide both sides. But now we can check the answer. If you want to plug 6 back in the original equations, look what happened. It's gonna be, we know the answer we find for x is 6. That means if we take 6 times 4 plus 5 must give us 29. So 6 times 4 is 24 plus 5. As we said, it must give us 29. So 24 plus 5 is 29 equal 29. We can say it's true, right? So we verify, we can check the answer. But looking at B, first of all, we need to use the distributive property, distribute that 4, okay? So we know it's gonna give us 8x plus 4. If you remember our distributive property, 29 has nothing to combine yet, plus 3 times 2 is 6x minus 15. We can simplify on the right side because we have 6x, 29 minus 15. That's something you can verify. I believe that should give you, when you do 29 minus 15, it should give you a beautiful positive 14. Now, two ways. We can subtract 6x from both sides and make sure 8 minus 6 is 2x. We keep our 4 in this side. 6x minus 6x is gone, so we have 14. Now, subtract 4 from both sides. It gives you 2x equal 10. Now, when you divide both sides by 2, I bet everyone can do this one, so x would be equal to 5. Now, try to plug x equal 5 in the original equations and make sure it gives you the same exact thing. So what we should be doing, all right, what we should be doing when solving a linear equations, if you go step by step, step-by-step procedures for solving a linear equations in one variable. Well, sometimes you don't need to respect all those steps, but generally you simplify the algebraic expressions on each side by removing grouping symbols and combining like terms. Like if there is a parenthesis, a number outside of the parentheses, you must distribute first, then you combine like terms. Second of all, you collect all the variable terms on one side and all the constant terms on the other side. So left or right, doesn't matter where you put them, but as long as all the x's with the same exponent one side and all the constant term on the other side, then you simplify, you isolate the variables and solve. Check the proposed solutions in the original equations to make sure that's what you find is a correct answer. All right. So I'm pretty sure you see what it is, you can get it. And that's exactly what we just did with, for example, B right there. Now, how about with linear equations with fractions? Okay. That's something definitely different, all right? So when you look at this linear equation with fractions, the fraction terms, first of all, you need to verify the denominators. You see the denominators here, they are 4, 14, and 7. So what number would divide 4, 14, and 7 at the same time? Because you need to find the smallest number that is divisible by 4, 14, and 7. So you can do all those type of multiplication, or you can list the multiples of 4. Let's say if we use 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, etc. If we take 14, we can say 14, 28. Oh, now look at this one. I find 28 here and 28 here. I'm gonna try to see if 7 can give me something. 7 is 7, 14, 21, 28. Yeah, the smallest number that is can divide 4, 3, and 12 at the same time is 28. So that means our LCD, the least common denominator, is 28. Okay, so I'm gonna erase this part. All right, let's erase because we are able to identify. With some practice, it's easy to find it. Two ways to do that. You can either multiply both sides by the least common denominator. That's the first thing to do. For examples, let's say you multiply this one right here by 28. Okay, I'm sorry, not 28. Okay. I'm gonna do it like least common denominator. What you should multiply 4 with to obtain 28. Yes, 7 times 4 is 28. So we do the same with the top part, okay? And then you multiply 14 by what to obtain 28? Yes, 2. So 2 times 5, 28. Remember, whatever you do with the bottom, you must do it also with the top. To obtain 28, you multiply by 4. Okay, look at this, what happened. you end up having 4x minus 12 over 28, okay, equals 2 times 5 is 10 over 28 minus this 4 times x. Remember that negative outside need to, okay, if I keep the fraction bar, you know what? I'm gonna keep it 4 times x plus 5. Let's keep the parentheses over 28. Now, when you have the same denominator both sides, that means it's like you can multiply both sides by 28 and get rid of, oops, sorry, not this. You can multiply both sides by 28 and get rid of the denominator, all right? So if you multiply both sides by 28, remember you can cancel out this 28, so you have only 4x minus 12 left. And look at this one. If you distribute 28 for the second, we're gonna have 28 times 10 over 28 minus 28 times 4 times x plus 5, okay, over 28. Now look, you can cancel that 28, you can cancel that 28. So what we have left is 4x minus 12 equal 10 minus 4 times x plus 5. As you can see, I didn't distribute the 4 in front of my second term on the right because of the negative sign outside of it. Now I can distribute because you can see how I would distribute the negative sign, because when you have the fraction bar, it makes it much difficult for you to see it. So we have 4x minus 12 equal 10 minus 4x minus 20. Hopefully you can see why we have negative 4x, negative 20, because we distribute the negative from the outside. So 4x minus 12 give us negative 4x, 10 minus 20 give us negative 10. How about we add 4x to both sides? It gives us 8x minus 12 equal negative 10. If we add 12 to both sides, what we end up having is 8x equal 2, okay, because we cancel out the 12 and the negative 12 plus negative 10 plus 12 give you 2. If you divide both sides by 8, you obtain a 2 over 8. Remember, these two has a common factor. I think I made a couple of mistakes. Let's see. We I have 4x minus 12. That's correct. 2 times 5 is 10. That's correct. Negative 4x minus 20. So what I didn't do correct, right? Oh, I see what happened. I multiply by 4, but okay. So I'm gonna erase this part because I multiply. Okay, this term is not correct. You know what? How about we do everything? We redo everything because I want to make sure that you see my mistake. Apologize for that because I don't know why I said 7 times 4 is 28, but then I changed my mind and I put a 4 instead of 7, right? Okay, you know how I do it. So multiply by 7, that means we have 7x minus 21 over 28 equal 10 over 28 minus 4 times x plus 5 over 28. Because, if you have the same denominator both sides, you can get rid of the denominators, all right? So we end up having only 7x minus 21 equal 10 minus 4 x plus 5. Let's distribute the 4, negative 4x minus 20. Now, if you add 4x to both sides, okay, guess what's gonna happen? We're gonna have 11x minus 21 equal 10 minus 20. What is that, please? 10 minus 20 is negative 10. Now, let's add 21 to both sides. We end up having 11x equal 11. Divide both sides by 11. This is just solving linear equations, and we are certain our solutions, usually we write solutions using an S with bracket like this, 1. Right? No parentheses, because if you put it inside of a parenthesis, it's gonna mean something different. Okay, very nice, beautiful examples, very quick on how you solve linear equations involving fractions. First of all, you identify all the terms in the denominator, look for the least common denominator, and try to multiply and divide. This is one of the techniques, but I'm gonna do another examples using a different techniques for you to see, especially when we have to deal with solving rational equations. You see, irrational equations is an equation that's contain one or more rational expressions, right? Remember, we solve an equations like only constant in the denominator, like this one, x minus 3 over 4 equal 4 over 14. So we had only constant. It was very much easier to do that. We were solving irrational expressions with constant only, right? But irrational equations may also contain variables in one or more of these denominators, right? So that's what make it different. You still need to look for a common denominator, because if you have something like 1 over x equal 1/3, or let's say 2/3, plus 5 over 3x, you see? That would be something different because we have x's in the denominators. That's a different type of equations, because the previous one was only involving fractions. Now it's a rational equations. To solve rational equations, you need to find the least common denominator. But first of all, focus on the numbers, on the coefficients. What is the multiples for 2, 18, and 3? What number can divide all 3? Yes, 18 can divide 2. 18 divided by 2 is 9. 18 divided by 9, 18 is 1. 18 divided by 3 is 6. So we know in our least common denominator, we're going to have 18. Now, looking at the variables, what variable has the highest degree? X. We just put x. Now, we know we can multiply both sides of our equations. So that's the second method we're going to use. We can multiply both sides of our equations by 18x. Now, look what happened. The first 18x, we're going to have 18x times 5 over 2x equal 18x times 17 over 18 minus 18x times 1 over 3x. So what I do, I distribute the least common denominator with both sides without multiplying yet. Because the reason why I don't multiply, because I see I can simplify. So when I cancel the x and I cancel 2 and from 18 as well, we have 9. So that means we're going to have 9 times 5 left on one side. Let's go here. We cancel the 18. So we have 17x left on the right, minus, we cancel the x's on the side, and then we cancel 18 and 3 has a common factor. When this one is gone, we have 6 left. We have 6 times 1. Now, what happened? We have 45 equals 17x minus 6. Okay? So when you add 6 to both sides, you end up finding 51 equals 17x. Let's divide both sides by 17, and you will realize that x would be equal what? Oh no, we said we can interchange, but not yet. So we're gonna have 3 equal x, or you can interchange, make it x equal 3. If this is okay for you, it's okay for me, because that's the purpose of doing all of this, is to rewrite it. Okay, we're gonna rewrite everything and make sure we do all of these correctly correct. Okay, so that's one thing. I wonder if I have to let you try the second one, or I need to help you all with that as well. First of all, identify the least common denominator for the second one. Let's identify the least common denominator. I'm gonna just take a green just to make sure. Okay, look, this one right there, we're gonna say, what is the least common denominator? When we have more than one term in the denominator, first of all, verify that you don't need to factor, okay? If you don't have to factor, you take the first denominator you see and keep adding factors using the other denominators that you don't see yet. Like in the second term right there, you see the denominator is the same. We don't need to use x minus 2 again. Now, the third one is 3. You see 3 is not in the first one, it's not the second one. And also, the third one doesn't have x minus 2. So what we're gonna do, we would multiply this one by 3. Usually, we would do LCD as 3 times x minus 2. That would be our LCD. Okay? Now, once you know the LCD, you can decide you're going to multiply both sides of our equations, but by what we don't have. Or you can simply multiply this side right there by 3 times x minus 2, and you multiply this side right there by 3x minus 2. Let's distribute and we'll see. We would see the first term is 3 times x minus 2 times x over x minus 2. The second one, we're gonna have 2 times 3x minus 2 over x minus 2, and minus 2 times 3x minus 2 over 3. Let's simplify. X minus 2 is gone when x is not equal to 2. That means on the left, we're gonna have only 3x left. X minus 2 is gone when x is not equal to 2. So we have 2 times 3, 6 left. And you see, if we cancel this one, then we're gonna have negative 2 times x minus 2. Let's distribute. If you distribute on the right, we're gonna have 6. Do not do 6 minus 2 equal 4, okay? Order of operation, distribute the negative 2, give you negative 2x, 2 negative give you positive 4, okay? Now, combine like terms. On the right, we have 10 minus 2x. Let's add 2x to both sides. It gives you 5x equal 10. Let's divide both sides by 5, x equal 2. Now, do you feel this one can be a solution to these equations? Do you feel this one can be solutions to these equations? Okay, I believed again we might make a giant mistake, probably not the correct answer. Let's see what we did. We multiply, we have 3x uh 3 times 2 is 6. We have negative 2x, positive 4. Is that correct? Yeah, yeah. I think this should be our beautiful answer. So you can always verify again and again and make sure the answer is all correct. But because x equal to 2, and if you plug x equal to in the denominator, we're gonna have, remember denominator is x minus 2. So that means if you plug x equal to 2, we're gonna have 2 divided by 2 and equal to 0. And because the denominator cannot be equal to 0, you will say the solution is empty. That means no solutions for this one. Yeah, or we can say it's inconsistent, right? Well, that's mean no solutions. It is there is no solutions for this one. It's not inconsistent, but it's no solutions. Okay, so we're gonna say no solutions instead. All right. The proposed solutions is 2 is not a solution because of the restriction that x cannot be equal to 2. Okay, so there is no solution to this equation. The solution set for this equation containing no elements, and usually we use that symbol to state that there is no element in the solution set, and we call it empty set, and we do it that way. Okay, it's not a 0, but we call it empty set. Okay, different ways of expressing it, but we're gonna keep it that way. All right, now C, solving a rational equation to determine when two variables are equals. Usually what we do, we just set them equals. All right, so if we set these two equations equal, because we want to know if the left side equal the right side, find all values of x for which y1 equal y2, because we know y1 must be equal to y2. So what we do, we go 1 over x plus 4 plus 1 over x minus 4 equal to 22 over x squared minus 16. When we have x squared minus 16, it's very difficult for us to identify the least common denominator. The best thing to do is to factor the that binomial. So we're gonna have x plus 4 plus 1 over x minus 4. On the right, we see 22 can be, because when we see x squared minus 16, it's the same thing writing x squared minus 4 squared. So that would be x squared, or x squared minus 4 squared give us something that you really know. When you have a squared minus b squared, it gives you a plus b times a minus b. All right. So it gives us x plus 4, x minus 4. Okay. Now, looking at this one, what we can do is to identify the least common denominator. And if I want to see least common denominator for this one, first of all, take the first factor we can find, multiply with the next factor that is different from the first one, multiply with the third factor that is different from the first and second one on the third equations. Looking at the third fractions, we already have everything. So we know on both sides of our equations, we would multiply by x minus 4, x plus 4. And in this side also, we would multiply by x minus 4, times x plus 4. What it gives us, you would see on the first equations, we're going to have x minus 4 times x plus 4 over x plus 4. That's the first term. Distribute to the second one. There is a 1, okay. 1 times x minus 4, x plus 4 over x minus 4, okay. One other things we need to see, on the right, we're gonna see 22 times x minus 4 times x plus 4 over x minus 4 times x plus 4. Okay, now cancel. X plus 4 is gone, so we have only x minus 4 left. X minus 4 is gone, so we have plus x plus 4 left. Okay. Okay. Now, on your right, x minus 4 is gone, x minus 4 is gone, but we need to set the condition, the restriction where x cannot be equal to negative 4 and x cannot be equal to positive 4 in order to cancel out. And what happened at this point, we can see on the right, we have only 22 left. Let's combine like terms. We see x plus x give us 2x on the right. And then 4, I'm going to put a different color for you to see because we can see that gives you 2x, but negative 4 is going to equal 22. Okay, so you really need to make sure you pay attention to this one. Now, divide both sides by 2. What you'll see, x would be equal to 11. Now, can 11 go in the denominator without making it equal to 0? Yes, because 11 can go in the denominator and not making your equation undefined, we can conclude that solutions is 11. That's the solutions. Remember, answers are not solutions. Answers are just solving equations. You can always find an answer. But if the answer, if you plug the answer in the original equations and it make the denominator equal to 0, you would conclude that there is no solutions. All right. Now, 3 different type of solutions to obtain when you 3 different type of equations. When you solve an equations, you can expect 3 answers. You either obtain a conditional one. It's a conditional equations when x equal to something and when x equal to something, that's it's conditional. You always solve and obtain something for x. We call that conditional equation. An equation that is true for at least one real number, but not all real numbers is called a conditional one. The examples that we have worked so far have been conditional. So you see, no, not all of them, because one of them is not, because I believe there is one where we find the answer was empty, right? I believe, yeah, I think that was this one. B was empty, so it was not conditional. An identity is a true for all real numbers, right? So identity is a true for all real numbers. It's like when you try to solve an equations and then you cancel everything. For example, let's say if they ask me to solve x plus 2 equal 3, if I subtract 2 from both sides, x equal 1 is conditional, right? That's a conditional equation. But identity, an equation that is true for all real numbers in the identity. Let's say, for example, I have 2x minus 1 equal 2x minus 2, okay? Now, when I distribute that to x, I have 2x minus 2 also from both sides. Now, what you see, when I try to combine like terms, I mean, isolate the x term, what you see? So I only find -2 equal -2. If you try at this point to get rid of it, you see you cancel out the x's. So there is no more x's, but that's true. -2 is really equal to -2. So you call this one. When you try to solve any equations, and by trying to isolate the variable, you cancel them out, you only constant remains. But the constant, these two constants remains, they are the same on both sides. You call it identity. So when you deal with identity, you know the solutions can be all real numbers. So solution for this one, we call it all real numbers, or you just put an R like this, or you can express it in terms of interval, or you can just write all real numbers. It's all real numbers. And consistent equations is an equation that is not true for all real numbers. That means when you try to solve, for example, if I have 2x minus 1 equal 2x plus 6, when after I distribute 2x minus 2 equal 2x plus 6, if I subtract 2x from both sides, you see I have -2 equals 6, which is not true. False. That's false. -2 is not here. -2 equal 2 is true, but -2 equals 6 is not true. So at this point, there is no solutions. We can also write it as empty, right? There is no solutions. So you can say no solutions, or you just said it's inconsistent. An inconsistent equation is an equation that is not true for every one real number. Okay. So if a true statement result, the equation is an identity that is all real numbers. If a false statement result, the equation is an inconsistent equation with no solutions. Now, in the homework, you might see a variety of examples where we would ask you, oh, verify if this or that, So if inconsistent, if it's real, if it's conditional, or is it identity? So you would do that. Now, we said solve and determine whether the equation is an identity, conditional, or inconsistent. All you need to do, 4x minus 7 stay where it is, but you can distribute that 4, okay? Then you simplify 4x minus 7 equals 4x minus 1, okay? Well, 4x minus 1. Now, if you add to both sides 4x, what's gonna happen? Look at if you subtract. So subtract 4x from both sides. What's happened? You end up with a solution where you have -7 equal -1. So when you try to solve these equations, you find -7 equal -1. That's totally false. So what would you say for this one as a conclusion? Its solutions is empty, or you can say inconsistent. Inconsistent equation, all right? This is an inconsistent equation because -7 is not equal to -1. And you see, by trying to solve, we cancel out the x's. If you try the second one where you have 7x plus 9 equal 9x plus 9 minus 2x, 7x plus 9 equals 9x minus 2x give you 7x plus 9. If you try to isolate the x term, you end up having 9 equal 9. Is it true? Yes, that's true, because 9 is really equal to 9. And then, remember, you cancel out your variables. So you only have a real number equals another real number, right? So once you see that, the original equation is equivalent to 9 equal to 9, which is true for every values of x. So the equations is an identity. So you can say solutions is all real numbers. Okay, solution is all real numbers. And we see that is equation is an identity, right? Yeah, I know, easy or not easy to check, but you know what? We're gonna do it. We must do it. We're gonna do it. All right. How we can come by and use equations in solving real life problems? Look at this one. Solving equation, apply problems using mathematical models. You know, that's something we ought to do because that's the purpose of doing all those mathematics, because we want to solve problems. In these particular examples, a person with a low sense of humor have higher levels of depressions in response to negative life events than those with a higher sense of humor. So it's a study. You know, statistics is used to conduct study about real life situations. So that's an example of a study conducted by a group or a research bureau. This can be modeled by the formula. This is a formula. Remember, there is always a formula behind all the computation we perform to solve real world problems. You either define the formulas yourself, or someone in the past, you know, worked on something that we can use to make our life better. So in this formula, X represents the intensity of a negative life event. So X represents the intensity. Remember, we have X represent the intensity, and D represent the average level of depression. So D, the depression, and X, the intensity. If the low sense of humor group average of a level of 10 inches, 10, so what do you think 10 represent? Look, X represent the density and D represent the level of average level of depressions. What is 10 represent? Thank you, that's represent D. So if 10, if D is 10, now when they ask you what is the intensity of the event, what do you think they ask you for? Yes, they ask you to find X. Now, I'm gonna use a different slide for that one. Okay, let's use a different slide. And also, I'm going to copy. Okay. Let me copy this. Okay, we're gonna copy this one right there and put it on a different slide. All right, this is the equations we have. Okay, we have that as an equations. And in the equations, remember D is 10 and the access to find X. D equal 10 and we need to find X. So when D is 10, we can rewrite it 10 equal 10x over 9 plus 53 over 9. Okay? Now, what is the least common denominator here? What is the LCD? You only have one of them, so that's 9. So what you need to do, multiply this side by 9 and multiply this side by 9. Distribute 9 times 10 is 90. Now we're gonna have 9 times 10x over 9 plus 9 times 53 over 9. That's give you 90 equal 10x plus 53. Now, if we subtract 53 from both sides, okay? So how about if you do 53, you do 90 minus 53, it gives you 37, right? Correct me if I'm wrong, equal 10x. Now, after I obtain 37 divided by 10 from both sides, so we have 3.7 equal x, or you can interchange and make it x equal 3.7. So by 3.7, so like remember, when you know x and y, it's like you have y. If you don't want to say d, you can say y. So that means you have 2 points. When x is 3.7, d is 10. And that's it. All right, you can say the formula indicates that if the higher sense of group average is a level of depression, of depression 10 in response to a negative life event, the intensity of that event is uh, uh, 3.7, right? So we said the formulas indicate if the higher humor group averages a level of depression of 10 in response to a negative life event, so the intensity of that event is 3.7, right? So we can illustrate it by that point, as I said, 3.7 and 10 on the line graph for the higher humor group, all right? So hopefully you enjoyed this section as well. As I said, in these sections, we went over linear equations and rational expressions. In the next video, please watch out for it, or you can check in the group to find it. It will be 1.3 on models and applications. I'll see you next soon in another video. Take care.